Good morning, good afternoon, good evening, wherever you are. Stay healthy. This is a lecture from your professor T. Freed Muhammad, Artificial Intelligence: The Next Frontier, an intermediate level discussion. Let us learn together something that is happening and surrounding us, the artificial intelligence. In the vast tapestry of human innovation, few developments have captured our imagination quite like artificial intelligence. At its core is the quest to imbue machines with the ability to think, learn, and make decisions. A pursuit that has a potential to redefine the very fabric of our society. From the humble beginnings of mechanical calculators to sophisticated algorithms that power today's smartphones, artificial intelligence has evolved into a force that is as ubiquitous as it is enigmatic. It is a technology that promises to augment human capabilities, automate mundane tasks, and even solve some of the world's most pressing problems. Yet it also raises profound questions about the nature of intelligence, the future of work, and ethical implications of creating thinking machines. We will be learning in this discussion the types of artificial intelligence, types of machine learning, supervised learning, unsupervised learning, reinforcement learning, deep learning, application of artificial intelligence to machine learning, and future of AI and ML. So, as we delve deeper into the realm of artificial intelligence, it becomes apparent that this technology is not a monolithic entity, but a diverse ecosystem of algorithms and techniques. Machine learning, or ML, is a subset of artificial intelligence, has emerged as a particularly powerful tool. ML algorithms enable computers to learn from data, identify patterns, and make predictions without being explicitly programmed. This capability has revolutionized fields as disparate as healthcare, where AI can diagnose diseases with unprecedented accuracy, and finance, where algorithms can detect fraudulent transactions in real time. However, the rise of artificial intelligence also brings with it a host of challenges. Issues such as data privacy, algorithmic bias, and potential for job displacement loom large, forcing us to confront the ethical and societal impacts of this transformative technology. AI is a simulation of human intelligence in machines that are programmed to think and learn, as mentioned earlier. Examples are Siri, Google Assistant, and Alexa are examples of artificial intelligence powered virtual assistants that can understand and respond to the human language. So, looking ahead, the future of artificial intelligence is both exhilarating and daunting. On one hand, advancement in AI could lead to breakthroughs in areas like personalized medicine, autonomous vehicles, and sustainable energy. On the other hand, the prospects of super intelligent artificial intelligence machines that surpass human intelligence in every economically valuable work raises existential questions about our place in the world. As we navigate this complex landscape, it is crucial to approach artificial intelligence with a balanced perspective, embracing its potential while remaining vigilant about its risks. In doing so, we can harness the power of AI to create the future that is not only more efficient and innovative, but also more equitable and humane. In the vast tapestry of human innovation, few developments have captured our imagination quite like artificial intelligence at its core. So we look at narrow intelligence, general artificial intelligence, and super intelligent artificial intelligence. One of the most tangible and immediately impactful forms of narrow AI, unlike the grand visions of general AI, which aims to replicate human like intelligence across a broad spectrum of tasks, narrow AI is designed to excel in specific, well defined domains, from voice assistants that understand and respond to our commands to algorithms that recommend movies and products tailored to our preferences. Narrow AI has quietly integrated itself into the daily fabric of our lives. The specialized form of AI is not just technological marvel, but a reflection of our ongoing quest to augment human capabilities and streamline our interactions with the digital world. As we explore the capabilities of narrow AI, it becomes evident that its strength lies in its focus, whether it's chess playing algorithm that can outmaneuver grandmasters, or a medical diagnostic tool that can identify diseases with remarkable accuracy. Narrow AI excels by honing in on specific tasks and optimizing performance within those constraints. This specialization allows for unprecedented efficiency and precision, transforming industries and enhancing our quality of life. However, the very nature of narrow AI also highlights its limitations, unlike general AI, which aspires to understand and adapt to a wide range of contexts. Narrow AI is confined to its predefined functions. This raises questions about the future of AI development and the balance between specialized excellence and versatile intelligence. Looking ahead, the trajectory of narrow AI is poised to shape our world in profound ways. As these specialized systems continue to evolve, they will undoubtedly play a crucial role in advancing the fields such as healthcare, finance, and transportation. Yet, the reliance on narrow AI also presents challenges, particularly in terms of job displacements and the ethical considerations of automating decision making. As we navigate this complex terrain, it is essential to foster dialogue that acknowledges the benefits of narrow AI while addressing its potential drawbacks. By doing so, we can ensure that developments and deployments of narrow AI contribute to a future that is not only more efficient but also more equitable and thoughtful. Facial recognition and internet searches are the examples of narrow AI. Okay, so in the ever expanding universe of artificial intelligence, general AI stands as the ultimate frontier of vision of machines that can understand, learn, and adapt to the world with the same versatility and breadth as human beings. Unlike narrow AI, which excels in specific tasks, general AI aspires to replicate the full spectrum of human intelligence, capable of performing any intellectual task that a human can. This ambitious goal represents not just a technological milestone, but a philosophical and existential leap, challenging our understanding of what it means to be intelligent and conscious. As we contemplate the potential of general AI, we are drawn into the realm of both immense promise and profound uncertainty. On one hand, general AI could revolutionize every aspect of human life, from solving complex scientific problems to creating entirely new forms of art and culture. It could serve as partner in innovation, collaborator in discovery, and catalyst for unprecedented economic and social progress. On the other hand, the development of general AI raises deep ethical and philosophical questions. How do we ensure that such powerful entities align with human values and interests? What are the implications for employment, social structure, and even the nature of human identity? This is a good question. Looking ahead to pursuit of general AI is a journey into the unknown, fraught with both excitement and trepidation. As researchers and thinkers grapple with the technical challenges of creating truly intelligent machines, society must also engage in a broader conversation about the ethical, social, and philosophical dimensions of this endeavor. By approaching general AI with a blend of curiosity, caution, and collective wisdom, we can navigate this uncharted territory with a sense of purpose and responsibility. In doing so, we may not be only unlock the potential of general AI, but also deepen our understanding of what it means to be human in an age of intelligent machines. So, that's the difference between narrow AI and general AI, where in the vast and rapidly evolving landscape of artificial intelligence, a super intelligent AI represents the pinnacle of ambition, a vision of machines that surpass human intelligence in every conceivable way. Unlike general AI, which aims to replicate human level intelligence, super intelligent AI aspires to transcend it, achieving cognitive capabilities that are far beyond our comprehension. This concept is not merely a technological aspiration but a philosophical and existential challenge, forcing us to confront the very nature of intelligence, consciousness, and our place in the universe. So, the self driving car is an example of narrow AI designed specifically for the driving tasks. Machine learning is a subset of artificial intelligence that involves training algorithms to make predictions or decisions without being explicitly programmed. Email spam filters use machine learning algorithms to learn from labeled data, spam versus not spam, to classify the new emails. The types of machine learning, supervised learning, we'll learn about this in a little bit more depth. Learning from the labeled data when we know that this is what it is. Unsupervised learning is learning from the unlabeled data where we don't know what it is exactly. It can be anything. Reinforcement learning, learning from interactions with an environment, and that's where we get the reward if we do something good or our algorithm does something good. Supervised learning. So the algorithm learns from a labeled data set which includes input output pairs. Predicting house prices based on features like size, location, and numbers of rooms is considered supervised learning. Let's look into this in a little bit more depth. Imagine you are in a real estate game and you want to predict house prices with less laser like accuracy. That is where supervised learning comes in. It is like having a personal coach who's seen it all and knows exactly what to do. Supervised learning is all about training your model on labeled data, meaning you have got a data set where you already know the outcomes. Think of it as giving your model a bunch of past examples to learn from. For instance, you feed it data on house sizes, number of bedrooms, locations, and their corresponding prices. The model learns from these examples, identifying patterns and relationships that help it make accurate predictions. It is like teaching a rookie salesperson by showing them successful deals and what made them work. Now let's dive into how this works in practice. You start by collecting a ton of data on houses, everything from square footage to the number of bathrooms, even the crime rate in the neighborhood. You label this data with the actual prices of the houses. Then you split this data into two parts, a training set and a test set. The training set is where your model learns the ropes, figuring out how different features influence house prices. Once it is trained, you test it on the test set to see how well it performs. It is like giving your sales team a practice run before sending them into the field. The goal is to minimize the difference between the predicted prices and actual prices, ensuring your model is as accurate as possible. But there is a kicker. Supervised learning is not just about crunching numbers, it is about understanding the story behind the data. When you are predicting house prices, you are not just looking at the raw figures, you are considering the context. Why is a house in one neighborhood worth more than a similar house in another? What features are buyers really looking for? Supervised learning helps you uncover these insights, making your predictions not just accurate but meaningful. It is like having a seasoned mentor who can see the bigger picture and guide you towards success. So, whether you are a real estate mogul or just starting out, supervised learning is your secret weapon for staying ahead of the game. Here you can look at apple, orange, and another orange, and apple and orange. The data that is given for the training, that's a labeled data set. And the prediction happens if we give as an input as a test data, whereas we as a human can see there's one apple and one orange. The prediction happens appropriately. That's how the supervised learning works in reality. I found this image by scrolling Google. So let's look into the unsupervised learning in a little bit more depth. In the world of data analytics, unsupervised learning is a silent operative working behind the scenes to uncover patterns that others can't see. Unlike its more straightforward counterpart, supervised learning, which relies on labeled data to make predictions, unsupervised learning operates in the unknown, sifting through mountains of unlabeled data to find hidden structures and relationships. Imagine you are a retail detective tasked to understanding tasked with the understanding your customers better than they understand themselves. You have reams of data on their purchasing behavior, what they buy, when they buy it, how much they spend, but no clear labels to guide you. This is where unsupervised learning comes in handy, like a seasoned investigator piecing together clues to solve a complex case. You start by gathering all the data you can get your hands on, every transaction, every click, every interaction. You feed this data into your unsupervised learning algorithms, letting it loose to find patterns and groups similar customers together. It is like setting a trap and waiting to see what you catch. The algorithm works tirelessly, sorting through the noise to identify distinct clusters of customers. Maybe one group prefers high end luxury items, while another is all about bargain hunting. Perhaps there is a segment that only shops during sales events, and another that buys consistently throughout the year. Each cluster tells a story, a unique profile of customer behavior that has that was hidden in the data or has been hidden in the data. But the real magic happens when you start to act on these insights. You tailor your marketing strategies to each segment, offering personalized experiences that resonate with their preferences. It is like knowing your enemy's next move before they make it, giving you the upper hand in the competitive retail landscape. Unsupervised learning does not just help you understand your customers, but it helps you anticipate their needs and desires, turning data into the actionable intelligence. In the end, it is not just about crunching numbers, it is about uncovering the truth hidden within the data, like a detective solving a mystery, one clue at a time. And in the world of business, that truth can be difference between the success and the failure. This is an example where we have the input raw data, which is unlabeled data, and interpretation happens by the machine learning algorithm. Interpretation then generates two different distinct data sets, and that's where we can see as a human that stars have been removed from the data set and triangles have been given as a different output altogether. This is again, I found this image through Google image search. Now let's look into reinforcement learning in a little bit more depth. In the labyrinth world of artificial intelligence, reinforcement learning stands as a daring explorer. navigating uncharted territories, and overcoming obstacles with unyielding determination. Unlike supervised and unsupervised learning, which rely on predefined data and patterns, reinforcement learning is a journey into the unknown, where the algorithm learns by interacting with its environment, much like an intrepid adventurer adapting to the challenges of an ever changing landscape. Imagine you are tasked with training a robot to navigate a complex maze, avoiding walls, and reaching the exit safely. This is where reinforcement learning comes into play, guiding the robot through the trial and error, rewarding success and penalizing failure. The robot, equipped with sensors and sophisticated artificial intelligence, embarks on its first foray into the maze. Initially, it knows nothing about the layout, the twists, the turns, the dead ends. It starts by making random decisions, exploring the maze, and learning from its mistakes. Each time it successfully avoids a wall and moves closer to the exit, it receives a reward, reinforcing the positive behavior. Conversely, each time it collides with a wall or veers off course, it receives a penalty, teaching it to avoid such actions in the future. This process of trial and error, reward and punishment, is the essence of reinforcement learning, a relentless pursuit of optimal performance through continuous adaptation. As the robot continues its journey, it begins to develop a mental map of the maze, learning the best routes and strategies to avoid obstacles. It becomes more adept at navigating the corridors, anticipating turns, and making split second decisions that ensure its progress. The algorithm behind the robot's AI is constantly refining its model, updating its knowledge with each new experience. It is like skilled navigator using a combination of intuition, experience, and a keen eye for detail to guide the robot through the treacherous maze. The more the robot explores, the more it learns and the more efficient it becomes at reaching the exit. But the true test of reinforcement learning comes when the robot encounters unexpected challenges, a sudden change in the maze layout, a hidden obstacle, or malfunctioning sensor. In these moments, the algorithm must adapt quickly, drawing on its past experiences and make informed decisions. It is high stakes game of strategy and survival, where the slightest misstep can lead to a dead end or a collision. Yet, with each challenge overcome, the robot's AI grows stronger, more resilient, and more capable of handling whether the maze throws at it. It is a testament of the power of reinforcement learning, a method that thrives on adversity and emerges stronger from any trial. In the end, reinforcement learning is not just about teaching machines to perform tasks, it is about instilling in them the spirit of adventure and the drive to overcome obstacles. It is about creating intelligent systems that can adapt, learn, and grow. So, hopefully, this has given you some understanding of reinforcement learning. This is an internal state, learning rat alpha, inverse temperature beta, and discount rate is uh, gamma. Let's say, for example, action goes, there's a cheese, and the reward is that you get a cheese, and the environment is a maze. And the observation is done by the reinforcement learning because the rat can smell cheese. Neural networks, a series of algorithms that mimic the operations of the human brain, permitting computers to recognize patterns and make decisions. Convolutional neural networks, or CNNs, used in image recognition tasks such as identifying objects in the photographs is a very good example for us to look into. The occupants, the size, and the temperature, when is given to a neural net, produces the electricity usage as an example. Let's look into this in a little bit more depth. In the fast paced world of technological innovation, neural networks have emerged as powerful tools for solving complex problems with unprecedented efficiency. Much like the lean startup methodology by Eric Ries, which emphasizes rapid experimentation and learning, neural networks allow us to quickly iterate and improve our models based on real world data. Imagine you are a startup aiming to optimize energy consumption in residential homes. You have data on the occupancy, size, and temperature of various houses, and you want to predict electricity usage accurately. This is where neural networks come into play, offering a flexible and robust framework for modeling complex relationships and making precise predictions. To start, you gather the data on the occupancy levels, square footage, and indoor temperature of different houses. This data serves as the input features for your neural network, just as a lean startup would begin with minimum viable product or MVP. You start with a simple neural network architecture, perhaps a few layers of neurons with basic activation functions. You feed this data into the network, permitting it to learn the intricate patterns and relationships that influence electricity usage. The key here is to start small, validate your assumptions, and iterate quickly based on the results. As you train your neural network, you continuously monitor its performance using metrics like mean squared error or accuracy. This is akin to the build, measure, learn feedback loop in the lean startup approach by Eric Ries. You adjust the network's parameters, experiment with different architectures, and fine tune the model based on the feedback you receive. For instance, you might add more layers or neurons to capture more complex interactions between occupancy, size, and temperature. You might also introduce techniques like dropout or regulations to prevent overfitting and ensure the model generalizes well into new data. The true power of neural networks lies in their ability to adapt and improve over time. As you collect more data and refine your model, you begin to see significant improvements in predictions accuracy. This iterative process not only enhances the performance of your neural network but also provides valuable insights into the factors that drive electricity usage. For example, you might discover that temperature has more significant impact on energy consumption than occupancy, permitting you to focus your efforts on optimizing temperature controls. Ultimately, neural networks enable you to create innovative solutions that are both efficient and effective, driving meaningful progress in your startup's mission to optimize energy consumption. Deep learning, a subset of machine learning that uses neural networks with many layers to model complex patterns in data. Deep learning models used in natural language processing to translate text from one language to other is one of the main examples of deep learning. The application of artificial intelligence and machine learning in healthcare, finance, retail, transportation are very visible in these days. The recommendation system on Netflix and Amazon Prime or standard Amazon shopping use machine learning to suggest movies and products based on the user behavior. How AI is implemented in healthcare, finance, retail, and transaction. Let's look at that with one example each. In the realm of healthcare, AI is not just a technological advancement, it is a beacon of hope, a catalyst for transformation, and a powerful ally in our quest for better health and well being. Just as Les Brown inspires us to reach for greatness, artificial intelligence empowers healthcare professionals to achieve what was once thought impossible. Imagine a world where doctors can diagnose diseases with unparalleled accuracy, where personalized treatment plans are tailored to each individual's unique needs, and where medical breakthroughs happen in lightning speed. AI makes this vision a reality by analyzing vast amounts of data, identifying patterns, and providing insights that can save lives and improve patients' outcomes. It is like having a superhero by your side, guiding you through the complexities of healthcare with unwavering determination and unmatched intelligence. But the true magic of AI in healthcare lies in its ability to inspire and uplift not just the medical community but every individual seeking a healthier life. Les Brown teaches us that our potential is limitless, and the AI embodies this philosophy by pushing the boundaries of what's possible in healthcare. From early detection of diseases to predicting patient outcomes, AI is revolutionizing every aspect of the medical field. It is like having a coach who believes in your potential, encouraging you to strive for excellence and never settle for mediocrity. With AI, uh, we can dream bigger, aim higher, and achieve more than we ever thought possible. So let's embrace the powerful tool, let it fuel our ambitions, and together we can create a future where healthcare is not just necessity but a source of inspiration and empowerment for us all. Now let's look into this, the next example of finance. In the dynamic world of finance, AI is more than just a tool. It is a game changer, a catalyst for success, and powerful ally in achieving your financial goals. Just as Zig Ziglar inspires us to embrace a positive attitude and take massive action, AI empowers financial institutions to make smarter decisions, optimize operations, and deliver exceptional value to their clients. Imagine a world where financial advisors can predict market trends and uncanny accuracy, where fraud detection systems are so advanced that they can identify suspicious activity in real time, and where the investment portfolios are tailored in each individual's unique need and risk tolerance. AI makes these vision a reality by analyzing vast amounts of data, identifying patterns, and providing insights that can transform the financial landscape. It is like having a supercharged engine driving your financial success, guiding you through the complexities of the market with unwavering determination and unmatched intelligence. But the true power of AI in finance lies in its ability to inspire and uplift not just financial professionals but every individual seeking financial freedom. Zig Ziglar teaches us that our attitude determines our altitude. And AI embodies this philosophy by pushing the boundaries of what's possible in the financial world. From automated trading algorithms that execute trades at lightning speed to robo advisors that provide personalized investment advice, AI is revolutionizing every aspect of the financial industry. It is like having a coach which believes in your potential, encouraging you to strive for excellence and never settle for mediocrity. With AI, we can dream bigger, aim higher, and achieve more we ever thought possible, as I mentioned earlier. So let's embrace this powerful tool. In the end, AI in finance is not just about crunching numbers and analyzing data. It is about creating brighter future for everyone. Just as Zig Ziglar inspires us to see the best in others and help them achieve their goals, AI enables financial institutions to provide better services, protect their clients' interests, and build more prosperous world. By harnessing the power of AI, we can overcome the challenges of the financial market, seize new opportunities, and achieve unprecedented levels of success. So let's embrace the power of AI. Let it inspire us to reach for the stars, and together we can create future with where financial freedom is within the reach for us all. Retail I have discussed earlier, and transportation is pretty much Tesla and any self-driving vehicle is the application of artificial intelligence. The future of AI and ML. The advancement of AI ethics, ensuring fairness and accountability as well as transparency. Explainable AI, making AI decisions understandable to the humans. AI in everyday life, increasing integration of AI in daily activities. Explainable AI in healthcare, where doctors can understand why an AI model recommends a particular treatment, ensuring trust and reliability. Let's look into this in a little bit more depth with an example each. The pursuit of ethical standards is not just a necessity but a moral imperative. Just as Napoleon Hill emphasized the importance of definite chief aim and a burning desire to achieve it, the advancement in AI ethics ensure that our technological progress is guided by principles of fairness, accountability, and transparency. Imagine a prestigious university, a beacon of knowledge and innovation where AI systems are deployed to enhance the educational experience for students and faculty alike. This institution recognizes that the power of AI must be harnessed responsibly, ensuring that it serves the greater good and upholds the highest ethical standards. At this university, AI is integrated into various aspects of campus life, for ambitions to academic support. However, the administration understands that with great power comes great responsibility. They establish an AI ethics committee comprised of esteemed faculty members, ethical philosophers, and technology experts to oversee the development and implementation of AI system. This committee ensures that AI algorithms are designed to be fair and unbiased, treating all students and applicants equally. Regardless of their background, they conduct regular audits and review to hold the AI systems accountable, ensuring that any decisions made by the algorithms are transparent and can be explained to those affected. Moreover, the university fosters culture of open communication and collaboration, encouraging students and faculty to engage in discussions about the ethical implications of AI. Workshops and seminars are organized to educate the community about the importance of ethical AI and to gather input on how to improve the systems. This collective effort ensures that AI initiatives are not only technically sound but also aligned with the values and principles of the university. By embracing these ethical advancements, the university demonstrates that the pursuit of knowledge and innovation must be grounded in integrity and commitment to the well being of all. Hopefully, this has given you some understanding of ethical AI. Let's look into the explainable AI with one example. In the bustling world of transportation, where efficiency and safety are paramount, explainable AI is emerging as a game changer. Just as Dale Carnegie emphasized the importance of effective communication and understanding in building strong relationships, explainable AI ensures that complex decisions made by AI systems are clear, understandable, and trustworthy. Imagine a city where autonomous vehicles navigate the streets, public transportation runs like clockwork, and traffic congestion is the thing of the past. This vision is within reach, but it requires more than just advanced algorithm. It demands the AI that can explain its actions and decisions in the way that everyone can understand. Let's take a closer look at the city's public transportation system. Autonomous buses and trains are deployed to optimize routes, reduce wait times, and improve overall efficiency. However, the true magic lies in the transparency of these AI systems. When the bus takes an unexpected detour or a train is delayed, passengers want to know why. Explainable AI provides clear, concise explanations of these decisions, building trust and confidence among commuters. For instance, if a bus reroutes due to traffic congestion, the AI can display a real-time map showing the congestion and the alternative route chosen to minimize delays. This open communication not only enhances the passenger experience but also fosters a sense of trust and reliability in the transportation system. But the benefits of explainable AI extends beyond passenger satisfaction. For transportation authorities and planners, understanding the reasoning behind AI decisions is crucial for making informed improvements and adjustments. Imagine a scenario where an AI system recommends changes to traffic light timings to reduce congestion. With explainable AI, planners can see exactly how the system arrived at this recommendation, including the data points and patterns it considered. This transparency allows for more effective collaboration and decision making, ensuring that the transportation infrastructure is continuously optimized for the benefit of all. In the end, explainable AI in the transportation arena is about more than just technological advancements. It is about building trust, fostering understanding, and catering a more efficient and reliable system for everyone, just as Dale Carnegie taught us that effective communication is the key to successful relationships. Explainable AI ensures that complex decisions made by AI systems are clear, understandable, and trustworthy. By embracing explainable AI, we can create future where transportation is not just efficient but also transparent, reliable, and trusted by all. Here is a little bit snippet of the code I have given, and I will explain this code in a little bit more depth. Here we are importing the necessary libraries such as NumPy, Pandas, and sklearn, as well as we are also getting some sample data which has feature and target. There are two sets of data that is provided. So we do the splitting of data by xtrain and xtest and ytrain and ytest by creating the test and train data simultaneously by the application of linear regression, and then we can also go ahead and predict, and the prediction you can see right on the bottom of the screen, and let me explain you this in a little bit more depth. So use of this algorithm is used in predictive analytics, finance, healthcare, real estate, education, and marketing. These are a few examples. In the predictive analytics, sales forecasting is the area. We're predicting future sales based on the historical data. Demand forecasting, estimating future demand for products or services. In finance, the example is stock price and risk management. So stock price prediction is where predicting stock prices based on historical data. Risk management is the area we're estimating the risk associated with financial investments. The same application can happen in healthcare. Disease prediction, we're predicting the likelihood of a disease based on the patient data. Patient outcome prediction, estimating the outcome of medical treatments. Real estate house price prediction, where is estimating the value of properties based on features like size, location, and number of rooms. And as we discussed earlier, so as healthcare we discussed earlier. In the arena of education, as I discussed earlier, where student performance prediction can happen by estimating student performance based on various factors like study hours, attendance, etc. Last but not the least, marketing is another area where we can apply this simple prediction algorithm. Customer lifetime value prediction, estimating a total revenue a business can reasonably expect from a single customer account throughout the business relationship. Use of libraries. NumPy is used for numerical computations. Pandas is used for data manipulation and analysis. Scikit-learn is used for ML algorithms. TensorFlow or Keras is for deep learning, and PyTorch for deep learning and research. Another code continues from the line 5, and this is a TensorFlow utilization, and here we are creating a simple neural network. And once that code is executed, we do compiling the model, and once we compile the model, it gives us, we have to train the model, and then we get the answer within the TensorFlow. So let me explain you a little bit more in depth. Suppose you are working for a real estate company and you want to predict the prices of houses based on their size, as discussed earlier, in square feet. You can use this code to train a neural network on historical data of house sizes and their corresponding prices. The model can then be used to predict the prices of new houses based on their size. You can customize the code to handle more complex data sets and features. For example, you can add more layers to the neural network, use different activation functions, and or apply more advanced pre-processing techniques to improve the model's performance. Let's continue with the PySpark. So when we use PySpark.sql and we import the Spark session, we create the Spark session in the memory, and you can use Python for that. I have used Google Colab. Sample data is Alice1, Bob2, Kathy3, and the columns are name and the value. Now creating a data frame, and when we execute that df.show, it gives us in a tabular format the resultant data sets. Deep learning is a subset of machine learning that uses neural networks with many layers of model complex patterns in data. The key features are the there are some key features which I'm going to discuss with you in a moment. Deep learning is a powerful type of machine learning that uses neural networks to analyze and understand complex data as mentioned earlier. One of its key features is its layered architecture. This means that deep learning models are made up of multiple layers of neurons, which work together to learn and recognize patterns in the data. For example, in image recognition, a deep learning model might use its first layer to detect simple features like edges and lines, while deeper layers recognize more complex patterns like shapes and objects. This layered approach allows the model to understand and interpret complex images accurately. Another important feature of deep learning is automatic feature extraction. This means that the model can automatically learn and extract important features from raw data without needing human intervention. For instance, in natural language processing, a deep learning model can learn the grammatical structure and meaning of sentences on its own without requiring predefined rules. This makes the model more efficient and effective at understanding and generating human language. Deep learning models are also highly scalable. This means they can handle large amounts of data and continue to improve as more data is added. For example, a deep learning model trained to recognize speech patterns can become even more accurate as it processes more audio recordings. This scalability makes deep learning models very powerful and adaptable to different types of data and applications. One of the most valuable feature of deep learning is its ability to generalize. This means that the model can apply what it has learned from training data to new unseen data. For instance, a deep learning model trained to classify images of cats and dogs can accurately identify new images of cats and dogs it has never seen before. This generalization ability makes deep learning models robust and reliable in real world applications. Deep learning models can also perform end to end learning. This means that the model can learn directly from raw input data to the final output without needing intermediate processing steps. For example, in autonomous driving, a deep learning model can take raw sensor data like camera images and LiDAR data and directly output steering commands. This end-to-end approach simplifies the process and makes the model more efficient. Another useful feature of deep learning is transfer learning. This means that the model can use knowledge gained from one task to improve its performance on a related task. For instance, a deep learning model pre trained on a large dataset of general images can be fine tuned to recognize specific types of medical images like X rays or MRIs. With much less data and training time, this transfer learning capability makes deep learning models very versatile and efficient. Finally, the deep learning models are very highly adaptable. This means that they can learn and adapt to new data and changing environments, new data and changing environments over time. For example, a deep learning model used for predictive maintenance in manufacturing can continuously learn from new sensor data and adapt to changes in equipment performance. This adaptability makes deep learning models very flexible and reliable in dynamic environments. In summary, deep learning is a powerful and versatile tool that can analyze and understand complex data. Its likely features, such as layered architecture, automatic feature extraction, scalability, generalization, end to end learning, transfer learning, and adaptability, make it highly effective in various fields, from images and speech recognition to natural language processing and autonomous systems. So, why use deep learning? High accuracy achieves the state of the art performance in many tasks, versatility applicable to various domains like image recognition, natural language processing, and speech recognition. Adaptability can handle structured data like images, text, and audio. Let's look into this with a few more examples. In the intricate dance of modern manufacturing, where precision and efficiency are paramount, deep learning emerges as a revolutionary force, akin to the astronomical breakthroughs that have redefined our understanding of the cosmos. Just as Dava Sobel illuminates the mysteries of the universe with her meticulous and captivating storytelling, deep learning sheds light on the complexities of industrial processes, offering unparalleled accuracy and insight. Imagine an auto manufacturing facility in Michigan, a sprawling landscape of machinery and assembly lines where every bolt and weld must be perfect to ensure the safety and performance of the vehicle produced. At the heart of the facility, deep learning models are deployed to oversee and optimize every aspect of the production process. These models, much like the telescopes that peer into the depths of space and are trained on vast amounts of data collected from sensors and cameras throughout the factory. They learn to recognize patterns and anomalies with a level of precision that surpasses human capabilities. For instance, a deep learning model can analyze high resolution images of welds, identifying even slightest imperfection that could compromise the structural integrity of the vehicle. This ability to detect and correct flaws in real time ensures that every car rolling off the assembly line meet the highest standards of quality and safety. But the true power of deep learning in this context lies in its ability to adapt and improve over time, just as astronomers refine their understanding of the universe with each new observation. Deep learning models continuously learn from the data they process. They can identify trends and predict potential issues before they occur, permitting for proactive maintenance and minimizing downtime. For example, a model might notice that a particular machine is showing signs of wear and tear, prompting maintenance crews to address the issues before it causes a breakdown. This predictive capability not only enhances the efficiency of the manufacturing process but also ensures that the facility operates smoothly and reliably. In the end, the integration of deep learning in an auto manufacturing facility is about more than just improving accuracy and efficiency. It is about pushing the boundaries of what's possible in industrial production. Just as Dava Sobel's narratives inspire a sense of wonder and awe at the mysteries of the universe, just deep learning inspires a new appreciation of the intricacies and potential of modern manufacturing. By harnessing the power of deep learning, we can create a future where industrial processes are not only more precise and efficient, but also more innovative and inspiring, much like celestial discoveries that continue to captivate our imagination. Now let's look into the versatility. In the ever evolving world of investing, where making a right decision or making the right decisions mean the difference between success and failure. Deep learning has emerged as a powerful tool that offers unparalleled versatility and insight. Just as Warren Buffett emphasizes the importance of the long term thinking and a deep understanding of the market, deep learning provides investors with the ability to analyze vast amounts of data and uncover hidden patterns that can drive profitable investment strategies. Imagine being able to predict market trends with uncanny accuracy, identify undervalued stocks, and make informed decisions that maximize returns while minimizing the risks. This is the promise of deep learning in the realm of investing. One of the key strengths of deep learning in investing is its ability to process and analyze large data sets quickly and efficiently. In the past, investors relied on traditional methods of analysis, which were often time consuming and limited in scope. Deep learning, however, can sift through mountains of data, including historical price movements, economic indicators, and even social media sentiment, to identify trends and patterns that would be impossible for humans to detect. For example, a deep learning model can analyze years of stock market data to predict failure or the success of future price movements with a high degree of accuracy, permitting investors to make timely and profitable trades. Moreover, deep learning can be applied to a wide range of investment strategies from quantitative trading to portfolio management. In quantitative trading, deep learning algorithms can execute trades at lightning speed, taking advantages of short term market inefficiencies and generating profits in the process. For portfolio management, deep learning can help investors optimize their asset allocation, balancing risk and reward to achieve long term growth. By leveraging the versatility of deep learning, investors can tailor their strategies to suit their specific goals and risk tolerance, ensuring that they are well positioned to navigate complexities of the market. But the true value of deep learning in investing lies in its ability to adapt and learn from new data, just as Warren Buffett advises investors to stay informed and adapt to changing market conditions. Deep learning models can continuously improve their performance by learning from new data and refining their predictions. For instance, a deep learning model trained to predict stock prices can be updated with the latest market data, permitting it to adapt to new trends and make more accurate predictions over time. This adaptability ensures that investors are always one step ahead of the market, ready to seize new opportunities and mitigate risks. In conclusion, the versatility of deep learning in the area of investing is a game changer, offering investors the tool they need to make informed and profitable decisions. Just as Warren Buffett's investment philosophy is grounded in long term thinking and deep understanding of the market, deep learning provides investors with the ability to analyze data, identify trends, and adapt to changing conditions. By embracing the power of deep learning, investors can navigate the complexities of the market with confidence and achieve long term success. So, if we continue that in terms of another area of opportunity, in the critical mission of to preserve our climate, adaptability is the key. The deep learning stands out as powerful ally, just as Warren Buffett emphasizes the importance of long-term thinking as mentioned earlier and strategic adaptability in investing. Deep learning offers unparalleled flexibility and insights in tackling the complex challenges of climate change. So let's look into this with another set of example that comes to my mind to share with you. In the face of the climate crisis, one of the most pressing challenges of our time, the adaptability of deep learning emerges as a beacon of hope. Just as Al Gore has tirelessly advocated for immediate and decisive action to combat climate change, deep learning offers a powerful tool to analyze, understand, and mitigate the environmental threats we face. Imagine a world where we can predict climate patterns with unprecedented accuracy, optimize energy use, and develop sustainable practices that safeguard our planet for future generations. This vision is within the reach thanks to the versatility and intelligence of deep learning. One of the most compelling aspects of deep learning in climate preservation is its ability to process and interpret the vast amounts of environmental data. Traditional methods of climate modeling often struggle to capture the complex interplay of various environmental factors. Deep learning, however, can analyze data from multiple sources, including satellite imagery, weather patterns, and pollution levels, to identify trends and patterns that are crucial for understanding and addressing climate change. For example, the deep learning model can analyze historical weather data to predict future climate patterns, enabling policymakers to make informed decisions that protect our environment. This capability is not just about the data analysis, it is about turning data into actionable insights that can drive meaningful changes. But the true power of deep learning in climate preservation lies in its ability to adapt and learn from the new data also. Just as Al Gore has emphasized the importance of staying informed and adapting to changing environmental conditions, deep learning models can continuously improve their performance by learning from new environmental data and refining their predictions. For instance, deep learning models trained to predict air quality can be updated with real time data, permitting it to adapt to new pollution sources and make more accurate predictions over time. This ability uh, technically comes with the adaptability, ensuring that our climate preservation efforts are always informed by latest data and are capable of responding to new and emerging challenges. It is about the being proactive, not reactive, in the fight against climate change. So hopefully this has given you in-depth understanding that why deep learning is so important for us to utilize. Thank you so much for spending this time with me and learning the artificial intelligence as the next frontier a little bit in depth so you can apply these concepts in your next AI, machine learning, data science endeavors. Happy learning.